Welcome back, guys. We are now moving on to transformations of tangent graphs. So hopefully you've already watched my sine and cosine transformation video. That's got a lot of information about the values we're about to use, but we're going to go jump straight into our graphs and take a look at our parent functions and how we transform it. Okay, so just like I did with my sine and cosine video, I have the parent graph of tangent already drawn in pencil, and then we're going to go in with some colors to show the transformation. So the first transformation I have is this value 4 right here. That coefficient changes the amplitude. We have an A value of 4. Now that's going to multiply all of my, or change all of my y values by a factor of 4. So now when I have a value of 0, well, that'll still be 0. And then this next point right here has a y value of 1. So I'm going to go over pi over 4, now up 4. So we are stretching by a factor of 4 vertically. We can also do that to the left. We go over negative pi over 4, and we're going to go down 4. All right, so now I've got my new stretched version of this tangent curve right here. We did not change our period, so we still have an asymptote right here at pi over 2, and then we're going to go ahead and again stretch our function right here. So our y value is 0, that's going to remain, and now we're going to go over pi over 4 up 4. Again, we're stretching. Same thing if I go to the left. Now we're moving down 4, and I will draw in my curve again. And we still have an asymptote at 3 pi over 2. So we have taken this graph and we have now almost like stretched it. If this was a string, we stretched it vertically. All right, the next type of transformation we have seen and will do is our horizontal stretch or compress. And that's when we change our b value right here. So our b value is 1/3, so it's theta divided by 3. And remember, to find our new period, we take the old one and divide by b. So our old period for tangent is pi, and we're going to divide by 1/3. Now if I do that, remember, if you divide by a fraction, you're really multiplying by the reciprocal. So this is pi times 3, which is 3 pi. What this means is our period used to be pi long, and now it's 3 pi long. What that really means is that we're multiplying all our x values by 3. Okay, so again, we have our x value of 0, that remains. And now, instead of going pi over 4, I'm going to multiply that by 3. So we're going to go over 3 pi over 4 and up 1. Same thing with our next value, so like pi. If I multiply pi by 3, that point is now at 3 pi. We also had a point here. We went over and up. Now from this point, we're going to go over 3 pi over 4 and up 1. So to kind of put that in simple terms, wherever the points were, we're just multiplying those x values by 3. So let me show you the math of that. This point right here used to have an x value of pi over 4. And if we multiply that by 3, now that's 3 pi over 4. Same thing with pi. When we had this point right here, if we multiply that by 3, that's now 3 pi. So as long as you know what those points are from your parent graph, you can just multiply all your x values by 3. Our last one that we have is this one right here. And then I'm going to draw in my curve. Now you'll notice I didn't do my asymptotes yet. I'll do that in just a moment. Okay. So our asymptote used to be at pi over 2, and if I multiply that by 3, so pi over 2 times 3, well, that's 3 pi over 2. So this asymptote right here is now the asymptote for that first curve. Then our next asymptote used to be at 5 pi over 2, so 5 pi over 2. If we multiply that by 3, that is 15 pi over 2. Now that one's off the graph. We can also do it with 3 pi over 2 used to be our asymptote right here. And if I multiply that by 3, that's 9 pi over 2. That one's on the graph right here. So this graph has been stretched horizontally. So we've kind of taken these and stretched in this direction. All right. Now we're going to do an example where we have a horizontal and vertical shift. We're just going to do it in one. Again, I have my parent graph, and we are going to talk about how to move these points. So pi over 3 is in the parentheses with our x value. This means this is our horizontal shift to the left. So we're going to go left pi over 3 because it's positive. And then we have a -2. We're going to go down 2 units. Okay, so now I'm going to take all of my points and do just that. So let's work with these points right here in the middle. If I were to take this point right here and move down 2 units and then over pi over 3, it's about 1/3. That's this point now. This one up here, if I move down 2 over about 1/3 or pi over 3, and then this last point right here, down 2 and over about 1/3. So remember, your x-axis, your tick marks, are each pi over 4. So I was just estimating about what pi over 3 would be. Okay, and then last thing I want to do is draw my new asymptotes. Now the asymptote is this vertical line right here. The only way this asymptote can change is moving left or right. So the only value that affects it is the pi over 3 to the left. So I'm going to take this asymptote and I'm going to move over about 1/3 or about pi over 3 and draw that in. Okay, so I've got my right asymptote. And then I'm going to take this one right here, again, move it over about 1/3. So right here. And now you can see I have my 2 asymptotes to draw my tangent graph in. So what I want you to see here is that this graph right here in pencil, the parent graph, has shifted down 2 and over 1/3, and now we have our blue graph. All right, last one I have on here is 3 different transformations, so let's combine them all and see what we get. So I've got my parent graph down. Let's talk about what transformations I have. The first one is my a value. A is 1/2. So all of my y values are going to be multiplied by 1/2 or divided by 2. So I'm just going to say divide y by 2. The next value I see is my b value. So b equals 2. Well, remember, I have to take the old period value and divide by this number. So the period is going to be pi divided by b. And that really means that we are dividing the x values by 2. And then the last transformation I have is this plus 2. So that means we are moving up 2 units. Okay, so basically 3 transformations I've got to deal with here. I'm going to slide or translate my points, and then I will see what happens from there. So again, your first point is always the easiest. It's the 0, 0. That one's easy to move. So the first thing we're going to do is up 2 units, 1, 2, and 0 divided by 2 is just 0. So that remains the same. I'm going to do the same thing with this point right here and move it up 2. You know what? Let me finish this curve and then we'll move on. So this point right here is where we're going to start. Now with the parent function, normally I go over 1, up 1, or over pi over 4, up 1. But both values have been divided by 2. So now I'm going to go over pi over 8, or half, and up half. Same thing here, I'm going to go to the left half of what I normally do, and down half of what I normally do. So you'll see that this graph is just a smaller, more condensed version of the old curve. Okay. Again, our asymptote is going to change, right? Because we have stretched or compressed horizontally. So this asymptote used to be pi over 2. That's our x value, so we're going to divide by 2. Oops, divide by 2. and that's going to give me pi over 4. Okay, so we are going to now, instead of have an asymptote at pi over 2, it's going to be at pi over 4. So this is my new asymptote right here. And then we're going to reflect that over onto the negative side. So you'll see the original graph had asymptotes from here to here. It was 4 tick marks wide. Now the new condensed version has asymptotes that are 2 tick marks. Okay, let's draw one more just so you can kind of see a couple different curves. So I'm going to draw my next value here, over a half, up a half, over a half, down a half. Draw in my curve and end it with the asymptote. Now you'll notice I didn't use any of these points as reference. I just used what I know about tangent graphs. Once you graph the first curve, then it just repeats forever in the positive and negative direction. So all I did was just copy the shape over in the next set of asymptotes. All right, thank you for watching, guys. Hopefully you now have seen how to transform your sine, cosine, and tangent graphs. I'll see you later.